All right, so first thing we're going to talk about is circumcenter, incenter, centroid, and orthocenter. Very confusing, but hopefully we can narrow down the differences. Now, circumcenter is the center of the circle that touches all four of these. So it's equidistant from all of the corners. Okay? So you're going to do a perpendicular bisector of each side. So the middle of this perpendicular bisector, so it's 90 degrees. Okay, as you can see, it doesn't always hit the corners. And then this side is a perpendicular bisector. Cut it in half, right? 90 degrees. So this one over here is also going to cut right there. And sometimes it does hit the top. Not every time. So all of these sides have been cut in half. And this point right here is equidistant from all of the corners. Okay? So if I were to make a circle around here, touching all of these corners, that dot would be in the center of the circle. The circumcenter, because the circumference, okay, is the perpendicular bisector of all the sides. Now, incenter uses angle bisectors, okay? So the angle bisectors, okay, all the angle bisectors meet at one point that is equidistant from all of the sides. So incenter and circumcenter are opposites. Here you're perpendicular bisector of the sides to find a point that's equidistant from all the angles. The incenter, okay, what's inside of the triangle is angles, does angle bisectors to find a point that's equidistant from all of the sides. So if you know one of these, you know the other one because it's the opposite. Now, centroid is the median of each side. So you're starting in the corner and you're cutting the side in half. You're starting in the corner and you're cutting the side in half. And that point that you're meeting at cuts each line into a 1/3, 2/3 piece. So if one piece is 5, the other piece has to be 10, and the total length of the line has to be 15. Okay? Orthocenter is where the altitudes meet. So this is where the medians meet, this is where the altitudes meet. Altitude just means the height. So if I were to find the height of this, it would come straight down from here at a 90-degree angle. Doesn't cut the side in half because it's not supposed to. And then you keep on doing the same thing. You find the height. What if this was the base and this was the top? You would have come straight down. Okay? Where all of these meet is the orthocenter. If it's inside of the triangle, it is an acute triangle. If it meets outside of the triangle, it is an obtuse triangle. And if it meets on the actual side, it is a right triangle. And those are the 4 and their differences. Okay, so geometric mean. So what if A was 3 times more than B? Where's the center? Okay, so you're putting more weight on A. So if this is 3 times more, okay, so this is 1 out of 4. There's 4 scenarios happening, 4 pieces of weight. So A is going to get, so A is 2, 8, and it's going to get multiplied by 3/4. Okay? And the other one, which is B, is going to be multiplied by 1/4. Okay? And that, once we find these and add them together, the x's and the y's, we will have our geometric mean. So remember, the numerator multiplies, the denominator divides. So 3 times 2 is 6, 6/4. 3 times 8 is 24. 24 divided by 8 is actually 6. Then 1 times 3 divided by 4, that's going to be 3/4. And that's going to be, actually I should have written here, just left it 24/4. Let's leave it like that. And then this is going to be 5/4. Okay? Now I just combine them, and that'll be the center. 6, 4, 3/4. If I add them together, I'm going to get 9/4. 24/4 and 5/4. That's going to give me 29/4. And that is the geometric mean. Okay? Now, normally we'd divide them. If you don't see that, you would divide it and you'd get 24. 9 divided by 4 is 2.25. And 28 divided by 4 is going to be 7.25. And there we go. Okay? Now let's move this up a little bit. The area of the sector right here from A to B and the length from A to B. So the area of the entire circle is pi r squared. But we're not talking about the whole circle. We're only talking about 100 degrees of the entire 360. So 100 degrees of the entire 360. So now you're just going to multiply 100 over 360 times pi, radius is 3 squared. Okay? So if you have a calculator, you would just type that in exactly the way it's written. So it'd be 100 divided by 360, right? You find the answer, there it is, times 3.14 times 3 squared, which I know is 9. Okay, so normally you would square first, but I knew what 3 squared was, so I didn't have to do it first. Okay, so we press enter, and we get 7.85. So the area of this space is 7.85. Okay, if this was inches, it's going to be inches squared for this area. Now the length is going to be a straightforward number. Now this is only part of the circumference. The circumference formula is pi diameter. So now we just have to do, instead of the whole 360, just 100 of the 360. So the diameter is 6 because the radius is 3. So it's going to be 100 over 360 times pi 6. So we do that in the calculator. And we get 100 divided by 360. That equals that. And then we're going to multiply by 3.14. And we're going to multiply by 6. And we're going to get 5.23 repeated forever. And that's just going to be inches in this situation. Okay? Now we have one more sheet of paper to go through. Hopefully it doesn't take us too long. So, this one. So if that's 40 and these lines AD and AC are tangent to the circle, not only are these congruent lengths, they are also the same angle because tangent lines are perpendicular to the center of the circle. So they're going to be 90 degrees. So that's 90, that's 90, that's 40, that's 180, that's 40. That's going to make 220. I need to get to 360, so this has to be 140. Now let's talk about this one. So the center angle here, when it's not going through the center like it is here, is going to be the average of the two. So 50 plus 120, that's going to be 170. 170 divided by 2, 85. So this is going to be 85 degrees. And if this is 85 degrees, this one has to be 95 degrees because they are supplementary. They're also a linear pair. Now here. So here, you have to subtract these and divide by 2. Okay? Subtract them and divide by 2, and you get this one. So 100 minus 30 is 70. 70 divided by 2 is 35 degrees. So this is going to be 35 degrees. Here, these inscribed angles. Okay? So this inscribed angle here, AB, right? This is 100. So anything that uses this dot and this dot is going to be half of 100. So if I were to do this one here, that means that this one's going to be 50 degrees. But this one here also uses the 100. So it's also going to be 50 degrees. Okay? I want you guys to know that I could do it twice, like this. Okay? As long as it's using these two dots, the angle is going to be the same. I can draw another angle that uses those two dots. It's also going to be 50 degrees. Okay? Let's keep on moving. So this, when you're doing lengths here with secant lines, is going to be the entire line times the outside. So that's going to be 8 times 3. So 8 times 3 has to be equal to the entire line here, which is 2 plus x, times the outside, which is 2. So this is going to be 24 equals 4 plus 2x. We're going to subtract 4. It's going to be 20 equals 2x. Divide by 2. X equals 10. Okay? Now this one, when you cross multiply this, it should be the same number. So 2 times 5 should equal 4 times x. Okay? So 2 times 5 equals 4 times x. This is going to be 10 equals 4x. It's a one-step equation. Divide by 4. Divide by 4. 2.5 equals x. Then 2 and 8. So I'm going to find the surface area of this. I have to find the surface area of the two circles. So pi r squared is one circle, but this one has 2. So I'm going to multiply it by 2. Then I'm going to add the surface area of the centerpiece, which is a rectangle. This here is going to be the circumference of the circle, which is pi diameter, times the height, which is 8. So let's enter on all the numbers. 2 pi r squared is going to be 4, plus pi diameter is also 4 times 8. So this is going to be 8 pi plus 32 pi. You can put those together and you can get 40 pi. If you don't see the answer 40 pi in your options or all decimal points, you literally just multiply 40 times pi and you're done. Good luck.